Okay, cool. Um, Welcome, everyone. The project the team and I have been working on is called the Crosswalk. The sponsoring this project is the Los Angeles County, the Internal Services Department. Our liaisons are Chea Mack, John Neill, Tiffany Lee, and Mark Martinez. Our academic advisors are Dr. Russ Abbott, Dr. Jungsoo Lim, and the developmental team is myself, Daniel Geiser, Adryel Arizaga, Jordi Alejandre, Jesse Rodriguez, and Norin Chea. Okay. So the Los Angeles County purchase managers like to talk to other purchasing managers to compare prices they have paid. Like us, they want to know they got or are getting the best price for the item or service. However, this is where the problem lies because not every organization uses the same standard or taxonomy for the service or items. The two most widely used are the United Nations Standard Products and Service Code, the UNSPEC, and the North American Product Classification System, the NAPCS. While on the other hand, the Los Angeles County uses the National Institute of Government Purchase, the NIGP standard. The communication between two managers over items in their respective taxonomies is called the crosswalk, a process for translating items from one taxonomy to an item in another taxonomy. The question we were posed is how feasible is it to develop a tool to do the crosswalk? The work done this year is just the first step. The two taxonomy standards both are commodity standards. We are to translate one standard in the Los Angeles County to the UNSPEC. Now, the structures of these two standards are as follows. The county has a two-level system. The top level is the commodity class. The class level is the general category of the items. The lower level is the commodity item with a description and keywords about the particular item. Now, the UNSPEC has a four-level taxonomy. The top level is also the most general. This level is called the segment level. When you go down a level, it gets a little more focused, but still really general. This is called the family level. Each family has a lower level as well called the class level. The class level is still general, but gives you a better idea of what is possible to buy. The commodity level is the actual item the organization would be purchasing from the UNSPEC standard.
So let's give an example that we can follow throughout the presentation. What you see here on the screen is two items, two commodity standards in the UNSPEC standard, which relate to medical exam, protective masks, covers, caps. And the LA County standard in the middle is a broader standard that would encompass both of these. So the issue that we have is that since the UNSPEC is so much larger, that we have multiple standards, oftentimes more than even two standards that fit into the same standard inside the Los Angeles County standard. Next.
Daniel, are you running the slides?
Yeah. All right. So broadly to give a scope of the work, it can be fit broadly into four main categories. We first have to isolate the data, which would mean that we have to decide which pieces of the Los Angeles County hierarchy and the UNSPSC County hierarchy, the UNSPSC hierarchy, need to be used to be compared to each other. Next, we have to clean the data, and this step is very important to us. Could you go back real quick? Yeah, next we need to clean the data. This step is very important to us because we need to make sure that the data is consistent for ourselves and so that we get consistent results and that it's easier for us to work with. Next, we have to compare the data, which is the actual meats of this project, where we try to find accurate results and accurate comparisons between the two standards. And then after we do all our comparisons, we have to save this data somewhere and then display this data in a way that an end user would be able to understand. Next. So the first step being isolating the data. The main question to be answered is what level of the UNSPSC needs to be compared and what level of LA County standard should be compared. So next slide, please. So if you remember back to our example, and you remember the structure of the two, the UNSPSC has four levels, but the issue that we have is at the lowest level of the UNSPSC, there's about 148,000 entries, whereas the LA County standard only has about 6,600 entries. So that's a ratio of about 22 to 1, and just mathematically speaking, it's pretty much impossible to find good relationships between the two standards if we're going at the lowest level. So we took a step up into the UNSPSC hierarchy, and we see that the class level has only 7,600 entries, which is much more comparable on a mathematical sense. But there's a couple problems that arise with that. If you see on the left side standard, the medical exam protective caps and covers, that wouldn't really be related to the LA County's the LA County standard because above it doesn't relate as heavily, which is an issue that needs to be addressed in order to make an accurate crosswalk. And then on the right side, you'll notice that resuscitation supplies isn't a lot of words to go on, and it could match to a lot of things that may be inaccurate. So in order to combat this, you can see the highlighted hierarchy standards with a hierarchy chain that we use. We compress all of those together and form one long compiled phrase. And we would use that compiled phrase to compare to the Los Angeles County standard. Next.
So now we need to clean the data, just to have everything uniform and to get the most accurate results. To do this, we need to remove any stop words such as and, or, but, or any other stop words that are in the data. We replace abbreviations such as maint to maintenance, which is obvious for us to see that maint is maintenance, but to a computer, maint is just maint. We remove punctuations, periods, commas, parentheses, the most common within our data that we were given. And lastly, we convert all the letters to lowercase just to keep everything uniform. Next, please. So here's an example of the clean data. So this is from the LA County side, and it removed the majority of punctuation. It did remove stop words as well, not only from the LA County side, but from the UNSPEC side, it did the same thing. It removed the punctuation and all the stop words and everything else. Next, please. So now comes how to compare. Using a word-for-word approach would be much too tedious, seeing as we're working with an Excel file with around 148,000 rows. Not only that, not only would it take too long and be too tedious, but something, for example, like this, coolers, drinking water, water fountains would turn into cooler imbibing H2O fountain. And that just doesn't really work for what we need it to. Next. Instead, we use a word to vector approach. Essentially, it plots words in an n-dimensional graph given n number of features. And that's how it compares the words to one another. So as you can see, dog and cat are relatively near each other because they're both animals. And then mother, father, son, daughter, they're all near each other as well. They're not directly synonyms of each other, but they are all related to each other. So they're all grouped together. Next.
Okay, so in order to start working with any data, we had to find a way for the computer to understand. As Jordi already mentioned earlier, we decided to use word2vec. But it's not just a regular word2vec, it's a Google words2vec that allows us to convert human language into vectors. It can also be trained using any corpus that will position the vector in such that they share common context. And we fortunate enough that Google has a pre-trained word2vec model use 300 3 million word corpus with 300 features. It means that it will convert word into their vector representations with 300 dimensions based on their data sampling. For a better understanding, we give a simple example comparing between king, men, and women with 4 different features, as the first feature should be 4 different features represented by 4 different colors. As the first feature will be the leadership, the second feature will be the wealth, the third feature will be whether or not they are humans. Last but not least, it should be gender. So as can be seen, the first feature of king has this different color because he is a leader compared to average men and women. Again, on the second feature, he has different color as well because, of course, king have a lot more wealth compared to regular average men and women. On the third feature, they all have the same color because they're all humans. On the last feature, king and man has the same color because they both male, which is different compared to the last one, women, which is female. Next. So here's kind of word embedding. What is word embedding and why we need, and why it's related to words to WEC? Word embedding is a technique that Google used to convert human language into vectors. It is a language modeling and feature learning technique in natural language processing used to convert words into vectors. And again, to better understand the word embedding, we provide an example, easy example of comparing apple and cherry with 3 different features within a scale from 0 to 100%. So, which means when you see it's 0.7, it means that it's 70%. So for example, apple have the roundness of 70%, redness 90%, and bitterness it's 30% compared to cherry have the 80% roundness, 90% redness, and the 70% redness. And when we take in all these, the sum of all these values, we can use them to assign their vector representations. And this is the same process that Google words to WEX model use, but it's just in different number of features assigned by their neural network. Next. So now that we know what is word to WEX and the technique that used to convert a word into vector, which is word embedding, we can start explaining how our similarity comparison algorithm works. To explain the process of our algorithm, we're going to use a real sample from the standard UNSPEC and the LA County. We choose the example because it will show our algorithm does when the word is 100% match, 100% match, and when it does not 100% match, and when one standard has more word compared to other. So for the purpose of visualizations easier, we only use 2-dimension made up value instead of a real 300 dimensions value. So as can be seen, the word school from UNSPEC has 2 and 6, which is exactly matched to the word school in LA County, which has 2 to 6 vectors as well. And also the word supply on the second positions from UNSPEC has the vector of 6, 2, which is exactly matched to the word supply on the LA County in the third positions, which is also 6, 2. Next.
Now that we have converted all words from both standards into vectors and decided as a team that the larger standard should be compared to the smaller standard, we can start finding pairs of which words from base standard are the most similar to which words from standard 2. To do this, we will take one word at a time from the base standard, compare the Euclidean distance against each word of the smaller standard labeled as standard 2. When by smaller standard, we mean the standard with less words. Then we will determine which is the most similar word based on which had the smallest Euclidean distance value, meaning the distance, the vector distance between them. Next slide, please. Here's a basic visualization to better understand the process. We have our school supply standard example graphed in a 2D vector space to depict how we are grouping pairs. The blue ones are the base standard, and the black ones are the smaller standards, otherwise known as standard 2. By finding the nearest neighbor using the Euclidean distance, we can determine which words to pair up. For example, the pairs school and school. There's zero distance between them, so they are the most similar to each other, making them into a pair. The same case will go for the example supply and supply. But now we take a look at kit and equipment. Since kit is the larger standard, we will measure the distance between kit and equipment, kit and supply, and kit and school. Here we see that kit and equipment has the smaller vector distance, meaning they're the most similar to each other. In cases where one standard has more words, like shown here, the word set, we need to find the next nearest neighbor. Similar to kit and equipment, we are going to use a similar process. We will compare supply to set, set to supply, set to equipment, and set to school. Here, the next nearest neighbor will be considered school, since it has the smallest distance between each other. By applying this process for every word on the larger standard, we can create pairs of which words are most similar, like showing here on the right side. We paired up school and school, supply and supply, set and school, and equipment and kit. Next slide, please. Now that we have determined what words will be compared to each other, we can start calculating the similarity percentage. To calculate the similarity percentage, we use Wu and Palmer's algorithm, which calculates similarity based on where two words occur relative to each other in a hypernym tree. It also calculates based on how similar their word senses are within a corpus of a library called WordNet. WordNet is a lexical database for the English language. We could think of WordNet like basically like a thesaurus. It groups words based on similar contexts, and it contains their synonyms and hypernyms. Also, when I reference the word sense, it is a different meaning for a word based on the context of the word's usage. First, we will calculate the similarity percentage for each pair. As you can see, the pairs school and supply are exact matches, so they will return 100%. But in cases like kit and equipment, they have a 87.5 similarity because one of their word senses have similar meaning. And it makes sense because the definition of equipment is the necessary items for a particular purpose. And the definition for kit is a set of articles or equipment needed for a specific purpose. Their meanings are very similar. The same case will go for the pairs set in school. After finding the similarity percentage for every pair, to find the overall percentages of these two standards, we calculated the average percent, resulting in a 90% similarity. And this is how similar school supply set kit is to school equipment supply. Next slide, please. Using our algorithm, this is one of the many results we gathered. This example shows the results of an LA County standard with more words being compared against the UNSPEC standard. Like mentioned before, the UNSPEC is much larger when compared to the LA County, so some results would not be exact matches. Instead, it will be the top most similar. In this table, we show the top most similar results when comparing apparel operating, examining disposal caps, examination, paper ground, mask against the UNSPEC, and I will return topmost results like resuscitation mask, anesthetic gas mask, or facial support garments. Next slide, please.
Thank you. That is the conclusion of our presentation. I'd like to thank Cal State LA University for giving us this opportunity. I'd like to thank the advisors, deans, and counselors. And I'd also like to thank the Los Angeles County Internal Service Department for giving us this opportunity. Thank you for tuning in. And that ends the presentation. Does anyone have any questions or anything?
This is Dave Westlick. First of all, thank you for that. I get to thank God for people like you on this earth, because if I had to try to figure out what you guys are figuring out, it would never happen. So, you know, for that, I say thank you. I kind of did have a question. Is you worked with the ISD team, I know, but were there any other? I think I see Mark Martinez on the phone on the line too from our purchasing folks. When we went through this, did we actually end up doing a? I guess what I'm asking is, did we run through some trials of the algorithm and actually look at hard data? I know you had percentages up there, but how did you derive at those, and did they end up yielding actual data during the project?
So this is Mark Martinez. So in answer to your question, we actually the team examined a number of options and approaches based on the data that was provided. The data that was provided were two commodity standards. One is the UNSPEC, and the other is what the county uses, and that's real live production data. The standard that we provided from the county is the same standard we use in our enterprise financial systems to categorize commodities and services that the county procures.
Okay, so it was against real data then.
And to answer your question about if we, it sounds to me like you're asking, did we get any like tangible results or testable
Correct.
results? Yeah, so we did provide Mark and John I guess I would call it just a regular Excel sheet of a smaller version of the UNSPSC standard, matched up to equivalent items in the county standard. So like just as a like a functional review testing.
Thank you.
Yeah, this is John. Just a couple of notes on that as well. That we did, you know, this project took on a lot of real world aspects that a lot of projects do. Hey, Mark, can you? I think it's Mark. Can you mute your phone?
No, I didn't.
Oh. And so as a result, we kind of started on a different path and then kind of came back around to this about halfway through the project. And I think it's suffice it to say that we know that this is an iterative process, and there's a desire to continue forward with this, possibly with another student project, indeed, in fact. So it is against real data. It's kind of the first iteration through the data, and we think that we could do a lot more work with it. So
Dave, let me just add a couple more points. So this was never, the crosswalk is never going to be an exact match. Simply because as the students went through, you're looking at two totally different commodity standards with different hierarchical levels in terms of a taxonomy. But the challenge and really the goal is how close can we get to rationalize the two? The business implications are really large, especially now with what purchasing is going through with COVID. I mean, we're interacting with other agencies and counties. We're comparing and benchmarking what they're buying versus what we're buying, and they have different taxonomies. So the benefits for this and the applications for this are huge. The first iteration comparisons of the data produced by the team, there were some misses, but there also were some hits and some patterns that demonstrated some real matches as a result of the process.
Hi, this is Trinh from LA County, and I wanted to reiterate what Dave was saying. I was watching this presentation and said, thank God there's people out there like you guys doing this and coming out with a degree in something like this and looking at natural language processing and AI. I remember 30 years ago when I was at UCI, we did a small did a couple classes in AI, and it was complicated back then. So looking at this stuff, you know, take comfort in the fact that I'm sure you guys will graduate and be able to make a ton of money doing data scientist work. And I was going to ask what how we're going to be able to apply some of these algorithms to some of the challenges we're hitting right now. So I'm glad you talked a little bit about that, Mark. So being able to crosswalk items that we buy across other areas. I'm just thinking about in terms of, you know, with the COVID crisis, and inventory becomes so such a crucial element in terms of being able to identify what we have and what we don't have, and maybe in also with sharing inventories with other organizations. How can we use something like this to be able to do that, right?
That's and to John's point, John Neill's point, I think this was a good start. I think we did a lot within half the usual project, but I think there's more iterations we can do to get to a more refined crosswalk.
Sure. So one of the people who was going to join this morning but could not was Michael O. And Michael O is the general manager responsible for all the county purchasing. And so he sent along a note just as a thanks, and I'd like to read that to the team. It says basically said, as the general manager responsible for Los Angeles County purchasing, I oversee the nearly $2 billion of commodities procured annually by the county departments. The ability to benchmark items and pricing for specific commodities with other agencies is a critical success factor to ensure public tax dollars are being utilized effectively. The project at Cal State LA to explore the feasibility of developing a functional crosswalk to assist with the comparison of varying commodity standards from other agencies is both exciting for the county as well as a challenge for the Cal State team who worked on the project. The Cal State team's use of data science techniques and the varying results clearly indicate that both the high level of difficulty for developing such a comparison as well as the expertise and diligence of the team themselves. I would like to take this opportunity to applaud the Cal State team for their efforts and wish them the best in their future careers and endeavors. Michael O. So thank you all for that.
So let me add a couple of things. This is Russ Abbott. First of all, I want to thank John and Mark because they have been continually supportive. John is always a good cheerleader and has kept up the team's morale. And Mark has been there providing very useful and important information since we don't know anything about purchasing. So Mark provides all that kind of information and why it's important and all that kind of stuff. So thank you both. The project itself is really an interesting project. And that, as Trinh said, natural language processing is a difficult area. It's part of artificial intelligence, and it's still under development. This idea of vectors representing words, that's relatively recent. I think maybe a decade ago they started doing that. And one of the problems that you run into with natural language processing is to try to understand what words mean. And computers don't understand what words mean. And we still don't know how to program computers to understand what words mean. This vector approach is sort of a beginning. So think of the example. The example included stuff like disposable such and stuff. Well, disposable as a word all by itself has nothing to do with hospital supplies or anything like that. It's just, just a word. It means you can throw it out. So how do you deal with a category that uses the word disposable as part of its description? Same thing happens when you use the word paper. I talk about paper masks. Well, paper means paper. Normally, when you think about paper, it means stuff that you write on. If you're still writing on physical stuff. And yet that's not what paper means in this context. It means that the masks are made out of paper or the gowns are made out of paper. So the semantics of these descriptions, are really challenging. So in some sense, this is almost, or perhaps really at the level of a research project. So what was done this semester, and as John said, this part of the project basically started this semester. The fall semester went off in a really kind of different direction. So what was done in this semester was just beginning to try to understand how to deal with the semantics of these two standards. And as I said, it's a very interesting problem, and it's a difficult problem. I think it would be fun and interesting and worthwhile to work on it again. I hope you guys want to support a team to do that next year. And if so, I think that would be a great thing to do.
Yeah, we're very supportive of the school, and you know, the since I've been involved, which is now going on, I think 3 years, from an executive support level, we've seen high value and we've seen extreme talent coming out of your school, and I can't imagine that we wouldn't want to just continue this moving forward.
Okay, that would be terrific.
Mm-hmm.
And this is Mark. I would just add that, you know, it was a really great experience for me. It was really great experience working with the students, and I'm really hope that the students, it was a good experience for them.
Yeah, this is Daniel. I'd just like to say, like, this was a very interesting experience. I can speak for myself. It was a new, everything this semester and this past year was something new, but it was actually very interesting to see how a real life project would actually function and how it can change on a couple months. Okay, that's it.
Yeah, this is John. I just to tag on to all that. You know, we started the beginning of last semester with kind of an objective, and we started kind of exploring different tools that we could use to, in this particular case, it was to try to do ranking on vendor quality and stuff like that. And it just turned out to be a problem that just was not going to be able to be solved with the tools, and the approach wasn't going to work. But it sort of like gave us the toolkit we needed for when Mark kind of leaned in with this use case. And I really appreciate him coming in with this commodity crosswalk, because it was perfect for this type of work. And so yeah, the project in earnest for this started at the beginning of the semester, but it was like we were working through a bunch of tools in the first part of the semester, and so, or the first part of the year, I should say. And I will say that you know, I understand a little bit about the natural language processing stuff, but I've done some classes and I've learned a little bit about it, but I learned a lot from this project. And I have to thank Dr. Abbott because he refused to let the process be like, well, we're just going to use this model, and really forced everybody to understand what was that model doing. And so when you get into that part of this presentation where the students are explaining that, I really appreciate him really pushing the students in that area, because it's super important to be able to understand, not just I'm going to throw a model at something and it's going to do magic work, but to understand what it's doing so that you can apply that knowledge to other problems. So I think the team did a great job. I appreciate their flexibility and you know, really a great set of folks. I've really had a lot of fun working with you all, and looking forward hopefully to maybe doing more stuff with a different team next year. So
this is Trinh. So John, it sounds like you may be enrolling in Dr. Abbott's class next year, and we may see you on the other side of this project, right? But I thought it was something interesting that Daniel said in terms of, you know, how much this project can change in a couple months. So I was just wondering if there was, you know, besides the technology, which is, you know, obviously the impressive on the technical side of what we've done with this project, but just on the cultural side of working with a real life project with real life customers and real life situations where things can be so dynamic. I was just wondering if there was any component to this project in terms of project management or change management or anything like that.
So the question is, was there an aspect to the project that was new to the team members, something like that?
I'm sorry, did I break out or did I break up there?
Yeah, I wasn't quite sure what the question was.
Sure. So
Yeah, go ahead.
I was just referring to Daniel's comments about how this project had changed pretty drastically in 2 months. So I was wondering if there was a component to this project besides the technical piece of this, where it was around project management or working with customers, real life projects, and working with the changing dynamic of how a project works.
So this is Mark Martinez. I'd like to answer that question, Russ, before you do. So there was, when I came into the project, we had a really good meeting, and then it really fell into, okay, let's break the project into components. One obvious one was a discovery phase, and then so John and I did a lot of laying out the project structure, but we didn't prescribe everything. We really left it up to the students to lay out things like milestones, respective schedules, and so on. So there was a project management component to it, and the students did very well. And in addition to that, to all the students, you nailed the presentation. You were clear, you were articulate, and I'm really, really proud and impressed with you all.
Thank you.
Thank you.
Thank you.
So I don't know if Dr. Abbott was going to answer that or any of the students in terms of some of the challenges with the kind of the changing requirements, or again, just kind of the project management side of this. Because I think that piece of it, is going to be common when you get out into the real world to apply to any project, regardless of the technology. And I think it's a really important component too. But, and by the way, great job on the presentation as well.
So yes, you hit the nail on the head when you talk about things that are essentially new to the students. And that's what the Senior Design Project program is, one of the things it's all about. This is the first time students got to work on a long-term project. It's a project. Normally these projects are a full year project. And in this particular case, it was sort of 2 half-year projects. And the one that bore fruit was the second part. But it's a long-term project rather than a simple homework. Second aspect is that this is probably the only time that students work on a project with, in a team. Sometimes you may work with 1 or 2 other people, but you're working with 4 other people and a faculty advisor and an outside person. So that's a new experience. And then the outside person all by itself is a new experience. It's not just a homework project that's been assigned. It's, something that someone outside the school cares about. And so if you're doing a project that someone else cares about rather than the instructor says, do this, you really have to figure out what that other person is all about. Why do they care about it? What are the issues? And so that brings the requirements aspect of it, much more into focus. So a good part of most of these projects is figuring out what the requirements are. So project management, yes, Trinh, that's a major part of these projects.
And I would like to add, this is Adryel. I would like to add that there's probably the most jarring aspect of working on the senior design project is the fact that students typically have not worked in large teams and had to write collaborative code, and typically even on school projects, even when you split up into groups or teams, everyone writes a piece of it, and then you put those pieces together and they just kind of work because the school's assignments were designed like that. But when working in this project, we had, especially this research-based project, we didn't know what pieces we needed, what aspects would fit together, if they would fit together at all. And working with together as a team was probably the biggest barrier for us. Maybe I can't speak for all the development teams, but for ours, it was definitely a barrier.
That's great feedback. And obviously, it sounds like while it's a challenge, you guys for sure overcame it. It looks like so. Good job.
Thank you.
So these presentations are scheduled for an hour. This is unusual. Most of the time in these senior design projects, the presentations get 20 minutes each, but we have an hour. And we still have another 10 minutes. There's a little video that I played on one of the earlier presentations that it's just very amusing. It's like 2 minutes. Has nothing to do with this particular project, but if you wouldn't mind, I'd love to play it. Daniel,
Let's go for it.
Please, do so.
Daniel, you have to give me share privileges.
Go ahead. I allowed everyone to share now. Go ahead.
Okay, so let me get this going. Share. Okay, so this is, can you all see this?
Yes.
Sky frozen.
Yeah.
This is
we got it.
from I believe, and oh, you know, I think I didn't do that right. You know, when you do share, you have to enable computer. Okay, so what did I do with it? I'm so. Okay, so let me try this again. So this is the problem with technology that you're not used to. Okay, so this is an Australian news reporter or news show, and he's talking about an elementary school teacher who was a music teacher, and her response, or how she's dealing with new systems that you don't know anything about, and you're trying to use it to teach. So a couple minutes.
But of course, it is a tricky time for teachers, and they're doing a great job. And this music teacher summed up how many of them are feeling with this, I gotta say, really poignant song.
Hey, so as some of you guys might know, I'm a music teacher, and I found that one of the best ways that I can process the whole transition to online learning and teaching is to write a song. So I wrote a song. I'd like to share that with you guys now. Here we go.
Beautiful. That kind of summed up our day, I think, for that.
Okay, so that sums up many of our
Good stuff.
That was lovely.
Yeah, that was funny.
I will add that to my music playlist to listen to while I work.
Very accurate.
Right, okay, so thank you very much.
All right. Thank you, everybody.
All.
Thank you, everyone.
All right.
Thank you.
Thank you. You guys
Thank
have
you.
a rest of a good day.
Good job. And
Thank you.
I guess, Dr. Abbott, you need to figure out how we get the whatever data science assets that they worked on to us so we can have them. I don't know what happened with that part, but we can figure that out.
Yeah, you can get it, and they're all on the project page. Which
Okay.
you see, I can send you a link.
Great. Thanks again, team. It was a lot of fun. Good luck and everything. If you guys need anything, don't hesitate to send me an email.
Okay, thank you.
Thank you very much.
All right. I'll be ending the meeting now.